first priority is product quality. Electrostatic discharge, or ESD, can damage our products, causing them to malfunction or not function at all. ESD certification of all HP production employees is one step toward improving our product quality and keeping our customers happy. First, we will test your current understanding of ESD control. Do not put your name on any sheet. While you're viewing the rest of this video, we'll grade the test to measure your understanding about ESD. Stop the tape and take the test now. This class will teach you what you need to know to become ESD certified. At the conclusion, you will repeat the test you've just taken. If you correctly answer 90% or more of the test questions and demonstrate that you can correctly perform the daily self-check procedure, you will be ESD certified for a period of 1 year. If you do not answer 90% of the questions correctly, we will work with you to help you understand the questions you missed. To understand how to prevent electrostatic discharge, we must first know what causes it and how it affects our products. Let's start at the beginning. No, not that far back.
Lightning, a powerful electrostatic discharge dissipating millions of watts in a fraction of a second. The results are dramatic and sometimes tragic. An electrostatic discharge from your body to an electronic component is much smaller, thousands of watts in less than a millionth of a second. But the results are just as dramatic and tragic, at least for the component. Electrostatic discharge, or ESD, can occur at any stage in a product's life. ESD damage costs both dollars and dissatisfied customers. That's why everyone who visits or works in a static-sensitive area, from manufacturing and field service to subcontractors and suppliers, must follow precautions. And that's the purpose of this program, to show you how to reduce ESD damage. To do that, we'll learn what ESD is and where it comes from. Then we'll look at the 4 steps in the HP ESD control program. Creating a static safe work area, protective packaging and labeling, training and certification, and audits to check how we're doing. ESD is a sudden discharge of stored up static charge, like the lightning bolt. Static charge is usually generated by touching or rubbing an insulating material. Your hand touching a plastic bag, or even the soles of your shoes rubbing against the floor, generates a charge, which can damage static sensitive components. Just about every type of component is static sensitive, whether loose or on a printed circuit board. That's why ESD control is so important. To control ESD, you first have to create a static safe work area. Because insulators are static generators, you've got to make everything electrically conductive and then ground it. Insulating surfaces such as tabletops, carousels, bins, containers, and even some furniture must be replaced with special conductive ones and then grounded. Use only approved sprays and cleaners, because some will insulate the grounded surfaces and cause static buildup. If in doubt, check with your static coordinator. If there are insulating materials at your workstation that cannot be made conductive, they must be kept discharged with an air ionizer designed for static control. You are the key to a static safe work area. Your body can build up and store a static charge, and your skin is an electrical conductor. So the best method of control is to make sure you're connected to electrical ground at all times. That way, the static on you is discharged to ground instead of the sensitive components. A wrist strap works well if you're seated or stand in one spot. The wrist strap must be worn so that its inner conductive surface is in firm contact with your bare skin, never loose or over your clothing. Shoes with conductive soles or foot straps are more convenient if you work standing or walking about. But remember, they only work when you're standing on a grounded conductive floor or mat. To be sure of a good ground, both shoes should be conductive. Wrist straps or conductive footwear should be the first thing you put on and the last thing you take off. Wrist straps and conductive floors or mats are safe because they have a built-in current-limiting resistor. It prevents you from being shocked should you accidentally touch a power source. Because your clothing is an insulator, static charge can build up on it. One way to prevent this is to wear a special conductive garment over your clothing. For example, here's the static meter reading of my clothing. 3,000 volts. Now with a conductive garment on, I'll remeasure the charge. 0 volts. Notice how it drops when the conductive garment covers my clothing. Your static coordinator has already made these types of measurements to determine if the people in your area need to wear conductive garments. Other items made from anti-static material are gloves, sleeve protectors, and hair covers. Use them when you work around static-sensitive components. Finally, make sure there are no insulators capable of generating or holding a static charge in your work area, like this piece of carpet and foam parts holder. All boxes, bags, foam, tape, and tools you use must be made of conductive or anti-static material.
You can recognize antistatic materials because they're usually marked antistatic or colored pink or blue. Conductive materials are usually metallic or black. If in doubt, check with your static coordinator. Personal belongings such as clothing not being worn, plastic bags, plastic or foam food containers, and even hairbrushes are static generators and must be kept at least 12 inches or 30 centimeters away from ESD-sensitive components.
Let's review what we've learned so far. ESD is a sudden discharge of stored-up static charge. Static charge is usually generated by touching or rubbing an insulating material. Insulating materials such as glass, plastics, paper, and cloth are materials that do not conduct electricity. Therefore, any static charge generated by rubbing or touching these materials cannot flow away or dissipate. The charge stays put, or is static on the insulator. That's why we call the charge static electricity. This static charge may stay on the insulator for many minutes. Untreated insulators should not be in your work area. These insulators include unworn clothing and other personal belongings. When we talk about static electricity, we often mention the field that surrounds a charged object. For example, most of us have charged up a balloon by rubbing it on our clothing. After the balloon is charged, we feel something surrounding the balloon that can make our hair stand on end. This thing that surrounds the charged balloon is called an electrostatic field. Every static charge is surrounded by an electrostatic field. We know that the discharge of a static charge to a component can cause damage. In addition, the electrostatic field surrounding a charged object can damage a component. This damage can occur even when the component never directly contacts the charged object. For this reason, we want to protect ESD-sensitive components from both static charges and the electrostatic fields that surround charged objects. It's important to not allow charged objects anywhere in the vicinity of ESD-sensitive components. Let's look at two demonstrations that will clarify the concepts of static charge and electrostatic field.
Here we have an instrument called an electrostatic field meter, and this actually reads the electrostatic field that's generated by a charge. What I'm doing right now is I'm generating a charge on the plastic bin box, and now we will use the field meter to actually see the electrostatic field that's generated by the charge. Now, using Scotch tape, I'd like to demonstrate to you the concept of an electrostatic field. What I'm going to do is peel two pieces of tape off the roll, and as I peel the tape from the roll, I'm actually generating a charge on each piece. So piece number one, I've generated a charge. Peeling the second piece off, I'm generating another charge. Now I have two charged pieces of Scotch tape. Now, as I attempt to put these two pieces of tape together, you'll notice that they are repelling each other or staying apart. The cause of this is each piece has a charge on it, and we have an electrostatic field that now exists between both pieces of charged tape. Now, if I can neutralize the charge on each piece of tape, the electrostatic field will go away, and you'll see both pieces of tape come together.
Some insulating materials, such as plastic bags and foams, can be made using a special process that will not allow the generation of static charge on their surfaces. These materials are classified as anti-static. For example, incoming hardware such as screws or other non-ESD sensitive components are often supplied to us in plastic containers. These containers must be manufactured to make them anti-static, so they will not generate charges that may damage other ESD sensitive components in the area. Examples of these anti-static containers are pink or blue anti-static plastic bags and component tubes or boxes that are marked anti-static. These containers will not, however, protect ESD sensitive components placed inside from static charges or electrostatic fields outside the container. Anti-static containers are therefore not suitable for storing or transporting ESD sensitive components. Special anti-static notebooks, adhesive tape, and page covers are available for your use when they are needed in an ESD safe area. In some instances, an air ionizer may be necessary to maintain a static-free work area. Your static coordinator will place these in work areas where they are needed. Let's see how an air ionizer is used.
Here we have an ionizer, and the purpose of an ionizer is to neutralize any high static charges that may exist in a work area. And again, to demonstrate an ionizer to you, I'm going to use Scotch tape like I did earlier. I'm going to peel a piece of the tape off the roll, generating a charge. And then to make sure that we do have a charged piece of tape, I'm going to put it close to the field meter so that you can see that it is charged. And now I'm going to put this piece of tape in front of the airstream of the ionizer. Checking the tape again, you can see that the ionizer has completely neutralized the charge that existed on the Scotch tape.
Now let's talk about conductive materials, which are very different from insulators. Conductive materials such as metals, wires, and specially treated plastics and paper can rapidly carry away or dissipate static charge. They are safe in your work area when grounded or placed on conductive surfaces that have been grounded. Bags and boxes that have been made conductive are usually black or metallic looking. ESD-sensitive components are completely protected from outside static charges and fields when placed inside one of these containers.
Make sure you are connected to ground with a wrist strap or conductive footwear. When sitting, you must be wearing a wrist strap. To prevent damage from static charge on your clothing, wear a specially made conductive smock.
Conductive containers are therefore the only suitable containers for storing or transporting ESD-sensitive components. In other words, an ESD protective container is a conductive container. Let's watch an experiment.
Here we have an anti-static bag, and I just want to demonstrate to you that an anti-static packaging material will not protect your product or your assembly from any kind of an outside static field. Again, I'm going to use my field meter, and if we pretend that the field meter is a very sensitive IC or a printed circuit board, I'll place it inside the anti-static bag, and then using a charged source here, you can see that the electrostatic field penetrates the package. So your parts or your components are really not safe inside of an anti-static package from an outside static field. Now remember earlier we talked about conductive containers, And here I have a black cardboard box that's been treated to make it conductive. And we know that conductive containers also shield from an outside static field. So again, if I do the same experiment and place the field meter inside the box and place the cover over it, and again, influence the field with my pistol here, you can see that the needle doesn't move. Okay, let's see if a conductive container really works. We'll take the field meter again and put it inside of our conductive bag. And then again, we will generate electrostatic field using the gun. And you can see that the electrostatic field does not penetrate the package. So a conductive material will completely shield and protect your static sensitive parts from any kind of an outside static charge or field.
As you move about, you are constantly touching and brushing against objects in your environment. This will cause static charge to build up on your body. This charge needs to be dissipated by conducting it to ground. This is accomplished by wearing wrist straps and heel straps or other conductive footwear as shown in the following demonstrations.
This is a wrist strap. This is what we use to ground you when you're sitting at a static safe workstation. Now if you'll watch real carefully, I'll show you how to wear a wrist strap. This goes over your hand, onto your wrist. That's all there is to it. What we're really trying to illustrate to you is that we don't want you to wear a wrist strap and have it loose like you can see here. Wrist straps come adjustable, and as you can see, here's a tab that you just lift up, and then for a small wrist you just pull the wrist strap down to a small size or just adjust it to your wrist size, and that's all there is to wearing and adjusting your wrist strap. This is the heel strap that you will be wearing to accomplish the grounding of you as you're standing up. As you can see, it has a Velcro strip and a conductive ribbon. The Velcro strip fits over your instep, while the conductive ribbon goes down inside your shoe between your foot and your shoe. The heel strap fits onto the back of the shoe like I'm showing you here, with the Velcro strip coming over your instep. And this is just adjusted so that it's comfortable to hold the heel strap onto your foot. Then the conductive ribbon will go down inside your shoe, underneath your sock, between your sock and your shoe. And since we all perspire in our feet, that moisture layer is all that we need to draw the static electricity off of you, through your socks, to the outside portion of the heel, and then when you're standing on a grounded conductive surface, we're draining you of any static electricity that may be accumulating on your body.
Water is an electrical conductor, so it can encourage electrical discharge between some surfaces. Water is a particularly useful conductor because it tends to flow uniformly over surfaces like this. This is why foot perspiration improves conductivity in our ESD footwear, and why we use water-based lotions with our ESD wrist straps. And just as moisture on wrist straps and footwear improves ESD protection, so moisture in the air or humidity aids conductivity. Higher levels of humidity, above 50%, helps electrostatic energy dissipate. With low humidity, below 30%, high buildup of static charge can occur, increasing the possibility of a discharge that could cause damage. While humidity is a useful ESD prevention tool, too much air moisture can cause additional problems, such as sudden discharge, soldering problems, and even corrosion and so forth. In short, while optimum humidity by itself does not prevent ESD damage, working with other ESD prevention methods, ideal humidity can improve protection against electrostatic discharge.
What I want to do now is to show you the effects of an ungrounded person and the amount of charge that's built up on a body as a person just walks across the floor. So here I'm going to be scuffing my feet on the floor, and I'm going to place my hand over here on the instrument so that we can read any charges that's being developed on my body as I scuff my feet on the floor. And you can see there's a couple of 100 volts there, 30 volts. And now if I just reach over and touch the ground strap while I'm still moving my feet, you can see that there's no charges that are being allowed to build up on my skin as I'm grounded. And this is exactly what we want when you wear your wrist strap or your heel straps.
Static charge can also build up in your clothing, since most clothing is made of insulating materials. In order to prevent damage to ESD-sensitive components by your clothing, you'll cover your clothing with a conductive smock whenever you are in an ESD-safe area. Let's see the proper way to use a smock.
Now I'd like to talk to you about your smocks. This is not the proper way to wear your smock. We ask that you start with this snap and snap the smock completely, starting here, all the way down the front. If you'd like to push your sleeves up, that would be fine. Just make sure that when you push your smock sleeve up that you have bare skin exposed out here. Never take your smock sleeve and pull it up over your clothing sleeve so that you have clothing exposed out here. We just like to have bare skin.
In this division, we have designated some large areas, such as the PC area, as entirely ESD safe. Our goal is to eliminate all static generators from these areas. Occasionally, a visitor may enter an ESD-safe area without wearing conductive footwear or a smock. When this happens, politely ask the person to step into the aisle and put on heel straps and a smock. No, wait. We said politely. Now let's talk about how an electrostatic discharge, or ESD, can damage a component. It takes 3,000 to 4,000 volts before you feel a shock from electrostatic discharge, such as when you walk across a carpet and then touch a doorknob. Some integrated circuits can be damaged by anything over 50 or 100 volts. Some devices are even sensitive at 15 or 20 volts. Here's the problem. If you can't feel a shock until it reaches 3,000 volts, and the part you're working on is sensitive at 100 volts, you may never know when you've exceeded the sensitive level and damaged the component. Let's watch what happens when an ESD-sensitive component, such as a transistor, receives an electrostatic discharge. First, we cut the top off the transistor, which exposes the small chip of silicon that's inside. We then mount the exposed transistor on a microscope so that we can watch ESD damage as it occurs. Wires are connected to the leads of the transistor in order to easily apply static charge to the part. A component may be damaged by as little as 50 volts. When getting up from a chair, several thousand volts can be generated and appear on your body. This is more than enough to destroy a sensitive component if allowed to discharge to the component's leads. While looking through the microscope, we can actually see the damage as it occurs. Now, let's watch the damage produced by repeated electrostatic discharges. Notice that the damage occurs in locations throughout the component. Some of these events may immediately destroy the transistor. Others may only weaken the part and cause it to fail later in a product the customer has purchased. This type of damage is called latent damage. Latent damage is especially frustrating to us and our customers because it causes us to ship a working product that is doomed to fail while in the customer's possession. A scanning electron microscope gives us a clearer view of the damage caused by ESD. The craters and pits seen here verify that this transistor will never function normally again. During the 80s, HP Labs estimated that 25% of all product failures were a result of ESD. Bell Labs estimated 50% were ESD related. This cost the electronics industry billions of dollars, as well as unhappy customers. The first step in controlling ESD is to create a static-free work area by following these simple steps. Whenever possible, replace all objects that are static generators with conductive ones, and then ground them. Replace insulating surfaces with special conductive ones, then ground them. Use only approved sprays and cleaners. Clear your work area of all static generators. Keep all personal belongings away from the work area. Make sure you're connected to ground with a wrist strap or conductive footwear. When sitting, you must be wearing a wrist strap. To prevent damage from static charge on your clothing, wear a specially made conductive smock. Let's pause for a moment to answer any questions about the first step in HP's ESD control program. Now, let's continue with steps 2 and 3 of the ESD control program.
The second step is ESD protective packaging and labeling. Just as our products are packaged to prevent breakage, they must also be protected from ESD damage.
It's important that you visually inspect each bag for holes and severe cracks that may cause the bag to become ineffective. It's also important that you throw the bags away after 5 uses.
Be sure you haven't put any static generating material, such as this plastic envelope, inside the container. Then apply a static attention label. They remind everyone of the need for proper handling procedures. This is the preferred static label because it's only used for ESD. Sometimes you'll see the preferred label along with this military label. This is okay. The military label alone is not acceptable. Don't confuse static labels with high voltage warning labels. Labels with lightning bolts are not acceptable for static warning. So always use this preferred label. The third step in HP's static control program is training and certification. If you handle static sensitive products or work in an area where they're used, you must be trained and ESD certified.
Let's summarize steps 2 and 3 of the ESD control program. To protect against ESD damage, put static sensitive parts inside a conductively coated plastic or paper container. Label containers with static attention labels. If you handle static sensitive products or work in an area where they're used, you must be ESD certified. Now, back to the fourth and final step in the HP ESD control program.
Audits are the final step in our ESD control program. They're necessary to make sure we're doing it right, since even a moment's lapse can damage a product. There are 3 types of audits or inspections: the daily self-check, the monthly department self-audit, and the yearly facility audit. The daily self-check must be done by every person working in a static safe area. It consists of 10 steps. First, remember insulators are static generators. Then check that all your workstation ground wires are undamaged and connected. If you use grounded floor mats, check that they're not damaged or disconnected from their ground wires. If your workstation has a static control air ionizer, check that it's turned on and correctly positioned. Make sure that no static generators are put inside the conductive containers. Check that all conductive containers have this static attention label clearly visible on the outside. Check that no new cleaners, solvents, coatings, or sprays are being used without the approval of your static coordinator. Check your wrist strap or conductive footwear each day before starting work. While wearing the wrist strap, connect the cord to the tester and touch the test terminal. The tester should indicate your cord and wristband are okay. If you don't get a good indication, check with your static coordinator and do not handle any static sensitive items until the problem has been corrected. If your body grounding is by conductive footwear, stand on a grounded conductive floor or mat. Then touch the test terminal. In addition to the daily self-check, there's a monthly department self-audit that includes measurements of static levels and ground connections by your department static coordinator. The yearly audit of your entire facility is by an ESD expert. When you see your static coordinator or an auditor making static measurements, it shows your department's commitment to improved quality and productivity, as well as your safety. Don't assume anything. If you have any concerns or questions, check with your static coordinator.
As step 4 just indicated, the daily check of your wrist and heel straps is an important part of ESD control. The following demonstrations show how to perform this daily check.
Now, once you put your wrist strap on, you're not finished. The next thing that you need to do is to test your wrist strap and your cord to make sure they are functioning properly. In front of me here, I have a wrist strap tester. Wrist strap testers vary in size and style, but for our purposes here, we're using this one. And as you can see, it has a slide switch here on the side. With this particular model here, you have to make sure that the slide switch is in the up position all the way. Take the banana plug on the end of your wrist strap cord and plug it into the top of the wrist strap tester. Then you just simply press the button to check your cord and your wrist strap. In this case, is saying that everything is good. If you should test your wrist strap and cord and get this kind of an indication, that's telling you that you have a problem and you need to find out where the problem exists. First thing you want to do is to just simply unsnap the cord from your wristband. Use the little metal plate that you see on the inside of your cord and press it right onto the push button switch. And this way, we're going to check the cord to see if it's functioning properly. If you're able to check your cord and it is passing the test, you may need to try some IC lotion. Some people have dry skin and it's a problem getting conductivity through their skin. So we have the IC lotion available that you just use a little bit and then rub it on your wrist where you're wearing your wrist strap. Put your wrist strap back over and re-snap, and then test again. We have a footwear tester here that's located throughout the production areas, and this is what you'll use to test your heel straps or your shoes. When you approach the heel strap or shoe tester, you'll notice that it has an amber light. This light is telling you that there is power applied, and you see the letters HI, which is saying this is a very high resistance. It is not measuring anything right now. When you step onto the plate, you should light the green light, which says it is safe and everything is functioning properly. Should the red LED under the low initials come on, you should see your supervisor or your ESD coordinator, because at this point the resistance between you and ground is too low and it presents a safety hazard. Now when you walk up to a heel strap tester, there will always be a metal plate located in the floor. Never approach the tester and place both feet on the metal plate at the same time. We want you to measure one shoe or one heel strap at a time. So while you're standing on the metal plate, raise one of your feet and touch the metal bar. And in this case, we do have a green light which is saying, I am okay. And then simply just place the other foot on the metal plate and raise the opposite foot, and we still have a green indication. So in this case, both of my heel straps are good.
We have just covered the 4 steps in the HP ESD control program. All 4 steps must be done correctly to prevent static damage. Let's summarize these steps once more before taking the final certification test. Grounding yourself is the first line of defense to protect against static electricity in your work area. If you are sitting, you must be wearing a wrist strap. Conductive footwear is more convenient when you're walking about. Conductive footwear is required for both feet. Smocks must be worn to protect components from static charge on your clothing. Remove all static generators from your work area. If you have static generating materials in your workspace, which must be there, sprays can be used to treat these materials. Check with your ESD coordinator for the proper spray. When an ESD-sensitive component is placed inside conductive packaging, it is completely protected from any outside electrostatic field. Be sure you haven't put any static-generating material inside the container. Always apply a static attention label to the package. All Hewlett-Packard production employees must be ESD certified. While working at this division, you must be recertified every year. Once a month, our ESD auditor will perform an inspection to check for ESD program compliance. Among the things the auditor will be looking for inside an ESD safe area are: if you are sitting, are you wearing your wrist strap? If you are standing, are you wearing your heel straps or other conductive footwear? Are all ground wires properly connected? Are you wearing a smock? Is your smock snapped correctly? Are your smock sleeves covering all clothing on your arms? Is your work area free of static generators? When the audit is complete, your supervisor receives a copy. Names are not used on the audit, only station numbers. It's important for your supervisor to know where in the process non-compliance has occurred so it can be corrected. Our ESD program is only as good as each individual employee's ESD control practices. It only takes one unsafe workstation to jeopardize the product of an entire production line. Following the steps outlined in this presentation is the key to maintaining a static-free work area. Remember, quality products mean happy customers. ESD prevention pays off in higher quality and satisfied customers. Now you will take the final test and demonstrate your knowledge of the ESD control program. If there is an aspect you don't understand, we'll be happy to answer any questions.